Alright, so let's use that theorem to take a look at a couple of these examples. So, we're trying to express each one of these expressions as one integral. So the first one's pretty simple. We're going from 3 to 6 of f of a dA plus the definite integral from 6 to 11 of f of a dA. So these are the same, which is the first requirement. Second requirement is this one has to end where this one begins. Right? If that works, then we can combine this into one definite integral from 3 to 11. I hope you enjoy the sound effects from Julia Rowley.
Not very delicious.
Alright, so this one's definite integral from 3 to 11 of f of a dA. Let's take a look at number 6. This one doesn't match up quite the right way, right? This one ends at 7, this one begins at -3. But the ones, there are two that match up. All we need to do is switch these around. Thanks for joining the class. Alright, so -3 to 1 of f of u du plus the definite integral from 1 to 7. So adding doesn't matter which order we add two things, it's still going to add up to the same. So we just switch the order. Now this matches up properly because this one ends at 1, this one begins at 1, so it picks up where the last one left off. So we can do the definite integral from -3 to 7. Let's take a look at one more together and then I'm going to have you guys try some on your own. So for number 8, this one has a minus in there, but it has to work with addition. How can we change this, maybe from subtracting to addition, from what we learned the other day? Yep. Right, flip what? Them. Okay. The A and the B, right? If we switch these around, if we change this from 7 to 5, that means the area under the curve is going to be the opposite of what it was from 5 to 7. So if this was a minus, that's going to make this plus. Well, you probably weren't paying attention. And Julia, you just asked that question with the class starter. If we switch these, that makes it the opposite.
That's not the question.
What are you talking about?
You said, what if it went from 4 to 0 instead of 0 to 4?
Oh.
Make it the opposite, same thing.
Yes.
Alright, so now these are split up and set up properly where the first one ends, where the second one begins. So we can take the definite integral from 2 to 5. Oops, of h of x dx.